ladies and gents. All right, last lesson of the week. So, as I said, we're going to start Trig today. So, we're starting a whole new thing, which is, all right. But the good news is we're not going to have exercise on that. I'm just giving you throwing some definitions at you here. Okay. Now, you can kind of say that the world or the people in the world are divided into two. Okay? Those who like Trig and those who hate Trig. Okay, I personally like Trig. Okay? I'm not saying that I love all maths. There's certain things I don't like, but Trig, I think Trig is fine. Okay, so don't be worried about trigonometry. Okay, it's chill. It's okay. Right. So the basic place to start with trigonometry or Trig, as I call it, is a right angle triangle. Okay. So a few kind of things to get used to. Okay, so we've got right angle triangle. Okay, we'll say this is 90. This angle is theta. Okay, I don't know if you came across. Okay, it's a Greek letter pronounced theta. Okay, we'll use these thetas quite a lot. Now check out something here. Okay, so I've given capital letter A, B, and C. Okay, in capital. These are the apexes. Okay, the little pointy thing on the triangle. Be careful not to hurt your finger when you touch them. Okay. We also have small letters, A, B, and C. So these are the sides, the lengths of the triangle. So A is opposite A, B opposite B, and C is opposite C. So it's just little things that we need to know. Okay? Now I drew I drew a similar triangle. Remember, we learned about similar triangles last year. Okay, similar triangle. Also, this triangle is FDE. Okay, it has 90 degrees. F is in 90 degrees. Okay, and it also has theta. Okay, at this point I'm not bothered about the other angle. Okay, it's a similar one. It's kind of just like minimized. Okay, now what can I tell? What do you know about similar triangles? You know that if I take, let's say, this side A divided by C, it's going to be equal to D divided by F. There's a certain ratio between the sides, okay? A divided by C is equal to D divided by F, okay? And that's what I'm working here. This is the place to start. There's a certain ratio between the angles. So at that point, I actually get rid of that triangle. I don't care about him anymore, because what I'm looking here, or what's Trig all about, it's about ratio between sides in a right angle triangle, okay? Now, let's remind ourselves, what do we call this side, which is opposite the 90 degree? You're right, hypothesis. Okay? Not hypothesis, okay, hypotenuse. Okay, hypotenuse. Okay, I'm thinking about science. Okay, hypotenuse. Okay, if I misspell it, please forgive me. Okay, now that's the hypotenuse. Now, if I call this angle, if I look at that specifically at that angle, theta, then the side that is opposite the angle, this is the side that's opposite the angle, I'll call it opposite. Okay? These are just words we got to get used to. Okay? So that's the opposite side. That's the hypotenuse. This is the side that is next to the angle. And next to, we have a bit of a posh name for it, we call it adjacent. So this side, the B in this case, is adjacent. That's the hypotenuse, opposite the 90 degree. Opposite side, which is opposite an angle. Right now I'm talking about this angle, not that angle. And that's the adjacent. Obviously, if I was looking at this angle, at angle B, okay, then that will be the adjacent, and that will be the opposite. But that's it, okay? Now, are you ready for the definition? Here we go. Okay. So if I look at the opposite side, okay, and I divide it by the hypotenuse, okay? In this case, it's A over C. It's not always going to be A over C, but in this language of this triangle, it's A over C. That's going to be called sine theta. Sine theta. Okay, can you see that? You get S-I-N theta. Sine theta, it's basically a ratio. It's a ratio between the opposite angle, the opposite side, and the hypotenuse. Okay? Now I just want to lower it down a little bit so I'll be able to work underneath that. Whoop. Sorry about that. You fell here. I hope you didn't hit your head. Okay? Now, what about if I want to do, instead of the opposite, I want to look at the adjacent. So I'll do it in black, so we take the color. Okay, adjacent. The adjacent divided by hypotenuse. Okay. In this language of this triangle, it's going to be B over C. The adjacent over the hypotenuse. B over C. Well, that's not going to be sine theta. That's going to be cosine theta. C-O-S, cosine theta. Don't get nervous. Don't get stressed about these letters. That's just a ratio. It's just a ratio. Okay? And don't worry, we'll build more on that and we'll practice things. I'm just giving you a definition right now. So we've got the sine theta, we've got the cosine theta. Okay? The ratios of the opposite to the hypotenuse, adjacent to the hypotenuse. We're missing something, aren't we? We're missing something. What are we missing? The ratio between the opposite and the adjacent, right? So I'm just going to get you here to make sure you'll be able to see it. So if I want, and I'll use red for that, if I want to do the opposite divided by the hypotenuse, okay, you can see that, okay, in the language of this triangle, it's A, not the hypotenuse, sorry, I've done that, I don't want to do that again, okay, it's the opposite divided by the adjacent, that's what I want to do, okay, so it's A divided by B. A divided by B, okay, that's going to be called tan theta. Tan theta. Okay, so these are the three definitions that you got to work with. Now, I'm going to add probably a little bit more after this one. Yeah, just a tiny little. But the most important one is sine theta, opposite divided by hypotenuse, cosine theta, adjacent divided by hypotenuse, tan theta, which is adjacent divided by opposite. Okay? We're going to end it here, and I'll add a little bit later, maybe next week. We'll see. Take care, guys.